welcome everyone. I think people are slowly connecting here, and we will do this in a little slow pace at the beginning. But I really want to welcome you to this event of living labs for forest soils and trying to connect the pieces here. This is it's a warm welcome to everyone that is online. This is a fantastic event. We have an outstanding number of participants with over 100 participants from 29 different countries in Europe. My name is Hjalmar Laudon. I'm at the Swedish University of Agricultural Sciences in Sweden. I'm a professor in forest landscape biogeochemistry, and I'm trying to lead you through this event today. But let me start by presenting some of our co-partners. It is Jung from Poland and the Agricultural Ministry of Lithuania. So I thank those especially for helping to organize this today's event. So the idea with this webinar is primarily to promote new and living labs around the Baltic Sea area. I just want to also mention that this will be recorded so that you know that, and it will also be translated and then available for anyone that is interested to look at this later. So today we'll talk about living labs for forest soils and how we can connect the pieces. We'll start by this little introduction that I'm giving. Again, for those that missed that, my name is Hjalmar Laudon, and I'm at the SLU, or the Swedish University of Agricultural Sciences. We have 3 presenters today. We have William Lidberg, who is also from the same university as I am, SLU, who will talk about using AI innovations to identify vulnerable soils. We have Justus Mingalia from the forest, who is a forest business owner, specialist of innovation support in LAS in Lithuania. He will talk about forest soil issues for successful business development, challenges and opportunities. And then we have Czernek Musial from the Bureau of Forest Management and Geodesy in Poland, who will talk about Wetland Green Life project. And this will then be followed up by a wrap up, where we try to answer some outstanding questions that come out. So use the Q&A for right questions if you have any, and there will be maybe time for 1 or 2 questions after each presentation. So just to reiterate what you already know, of course, the soil missions. There are 8 different objectives, mission objectives that are relevant for soil issues in Europe. We have reduced desertification, conserve and increase soil organic carbon stocks, stop sealing and increase reuse of urban soils, reduce soil pollution and enhance restoration, prevent erosion, improve soil structure to enhance soil biodiversity, reduce EU global footprint on soils, and finally improve soil literacy in society. So these are key, the key 8 key soil missions that has been identified. The main goal of this program, of NATION's program, and one of the for the soil deal for Europe is to establish 100 living labs, and this should be done by 2030. So there is actually only 10 years, or 5 years to come before these should be in place. And these are places to do ground-based experiments and do really good innovative co-creation and develop the forest soil health across Europe. So the concept of living labs is actually more than just living labs. It's also lighthouses. And the difference between living labs and lighthouses are that in the living labs, they are user-centered, multi-stakeholder based, and they should really focus on real-life settings and be more than one specific location, but actually have several sites on a regional or sub-regional level. A lighthouse, in contrast, is really where you could showcase some good practice in upscale solutions. And there are places for demonstrating, training, networking, and communication. And it's really a place to inspire land users to develop practical tools for how to better implement our better understanding. So living labs and lighthouses can be best defined by their innovation and co-creation potential that can contribute to the societal challenges that we have when it comes to soil health. And the three presenters today will highlight some of these challenges and some of the solutions that we have out there. And remember, today we'll focus on one of 4 different potential living labs areas, and that's the forestry living labs. There are also other ongoing activities on agricultural land living labs, urban living labs, and industrial living labs. But again, the focus here is on forestry or forest living labs. This is a map of the living labs that we have across that has been started and this has been presented by a sister project called Prep Soil. And as you can see, there are not that many out there. There are a few across Europe, and as you can see, we are far from the 100 that is the target so far. So when it comes to potential soil issues in forestry, this is just an example from a workshop that we had in Sweden on this, and identify some of the main issues that we are dealing with here. What can be soil scarification, soil biodiversity losses, organic matter content, drought, of course, peatland drainage and wetting, nutrient leakage, and forest fires were identified as the most important aspects of this. Today we will focus primarily on the talks, soil scarification, rutting, and erosion, and then also on peatland drainage and rewetting. Again, I just want to present the 3 key actors here today: William Lidberg, Justas Mengalia, and Shermek Musial. Welcome to you, and I will be happy to then give the floor over to William.
Thank you. Now we just start to share my screen. Or I can just share my presentation instead, it's probably better. One second. Okay, now it should work. Do you see my presentation or the comment view?
Comment view.
All right. How about now?
Super.
Good. Right. Okay. I'm William Lidberg, the same university as Hjalmar, same department. And I'm going to talk about soil damage and how to use AI to prevent soil damage. I will start with some background with my favorite map, or one of my favorite maps. This is the population density of Sweden. And you can see that there is a clear trend that people tend to aggregate in some areas, and then we have a large part of the country which is more or less unpopulated or scarcely populated. So the trend has been that people are moving away from the countryside, away from the forest, out to the coast and into the cities. And this is a global trend. It's not only happening in Sweden. But this also means that it's very few people left in the forest. So we are managing the forest with a handful of people compared to what we used to 100 years ago. And to do this, we need a lot of automation, heavy machinery, and above all, we need accurate maps. And the problem is that since forest is covered by trees, and trees have canopies, it's really hard to see what's underneath the tree canopies, and traditionally maps have been drawn from aerial photographs. And if you can't see what's underneath the tree cover, you can't see the ground, the soil, or the streams. In Sweden, this had led to that most of the wet soils are missing from the maps. Only open peatlands are on the current maps. We're missing most of the streams as well, especially smaller streams, and essentially all of the ditch networks are missing. And if you don't have accurate information when you plan your forestry operations, you will end up doing a lot of soil damage. In this case, we have quite heavy machines in Sweden, since we have to be efficient and to keep the costs down. And, and since there's so few people managing it, we also need to be accurate. The problem is that when you drive these heavy machines over unknown wet areas, you will create these ruts. And in this rut, you end up with heavy metals like mercury accumulating and then leaching out into the stream, accumulating in fish and biota. You have sediment transport and erosion. You can even change the path of streams if you drive in the wrong locations. And this is something we want to avoid. Another issue, if you don't see what's beneath the forest, is that you have poor maps. In Sweden, we don't really have any soil maps for the northern or northwestern part of the country. We only have very rough overview maps. And with poor soil information, we end up with very expensive mistakes. For example, we were building a railroad, and due to some acid soils, it ended up costing a lot more than originally calculated. And another example of damage to infrastructure is if you don't know where the groundwater flow paths are or how the forest is drained, you can end up with damage on infrastructure as well, one you already have built. So the solution is in two parts. Part one is LiDAR. It's airborne laser scanning. You fly with an aircraft about 3 kilometers above the ground, shoot laser pulses down towards the ground, and count how long time it takes for these pulses to return to the sensor on the aircraft. And the ones we're mostly interested in are the ones that hit the ground, the ones that come back last. So from this, we can finally get a glimpse, or actually a lot of information about the ground and the surface topography underneath all these trees. And something that's really exciting is that almost all countries in Europe have LiDAR data now. Many have really dense LiDAR data, like Poland and Lithuania, for example, have really high quality LiDAR data to work with. The second part of the solution is artificial intelligence, or AI. On a very basic level, the whole concept is, instead of programming something with code, we program with data. And then the model builds themselves using the training data. So I have 3 examples to show. We have wet soils, how to map wet soils using LiDAR and AI. Hidden soils, that's like quaternary deposits. And finally, drained soils. So if we start with example 1, wet soils, we can have a look at the best map we have in Sweden right now. This is the Swedish property map, and it captures some of the wet areas. I have something called kappa value in the bottom, which is a value between 0 and 1, where 1 is perfect agreement with reality, and 0 is just random noise. In this case, this map has a kappa value of 0.39. So it does contain some wet areas, especially the open wetlands. But with LiDAR, we can start to model the water using topography. One very easy way to do it is to calculate something called depth to water. And these maps were developed in Canada, and we have been using them in Sweden since 2014. And the kappa value of these maps is 0.56, so it's a lot better. The issue with these maps is that they are static. They don't change depending on where in the country you are. So you might end up with overestimating or underestimating the wetness depending on if you're north or south in Sweden. But if we combine a lot of topographical data with machine learning and the Swedish forest inventory, we can make a really accurate soil wetness map. And this is what we've done for Sweden. And the kappa value is almost 0.7, so this is a high quality map. My second example is hidden soils. The purple areas indicate the areas of Sweden where we have a decent soil map, so the rest is just missing. But the topography of the soils do contain a lot of information about the ground. So in this image, you can see on the left, it's a bit more rugged. On the bottom right, it's a bit flat, which with sediment. And then you have some rolling hills, which is till soils. And using machine learning, we train a model on the areas of Sweden where we have good maps, and then we can apply them to the areas with poor maps. So here on the left, you can see the legacy maps. That's the rough overview map. And on the right, you have the AI-derived map, which is a lot better. So this is one way to extract information from LiDAR using AI. And for my final example, I will talk about ditches. These are small ditches created to drain wetlands and drain wet forest soil to increase forest production. And it has been done really extensively, especially in Sweden and Finland. The issue is that they are not on any map, like 99% of them are missing. So in this image, it's an image of natural streams in blue. We have road ditches in red, agriculture ditches in yellow, and then we have the forest ditches in green. So we have really changed the hydrology in Sweden. So what we have done is to train a deep learning model to map ditches using LiDAR. And we have then implemented that model across all of Sweden. And here you can see the comparison between the old topographical map on the left, and on the right, you have the detected ditches. So this is channel density, so the length of a ditch per square kilometer. So we have really changed the hydrology of Sweden. And the fun thing with this, or the cool thing with this method, is that it only requires LiDAR data to work. So we have tried it in different European countries, in Sweden, Finland, Latvia, and Poland, and it seems to work well in all these countries, especially in countries like Poland with really good high-quality LiDAR data. Then you can really detect all the channels, which is quite exciting. So I'm working with, we have both European projects where we can try these things around the Baltic Sea. We have a lot of open data, especially with the new EU framework. So we can use forest inventory data or national geographical data and implement these models across large areas quite efficiently. And I'm also working with both the big forest companies and not all, but most of the Swedish agencies which are relevant for these topics. And as for European collaboration, this is something I'm interested in. And I mean, we have the LiDAR data. We have a lot of training data in shape of forest inventories and other data. So I think we're quite ready to scale this up. We can implement these methods in all these European countries. And if you're interested, just get in touch. And with that, I would like to just show some examples. We can map wet areas, soils, ditches, and also groundwater flow paths. And thank you.
Thank you very much, William. Great to see this. And while we set up for the next for Yutas Mingalia, any questions for William? The burning question that you might have. Otherwise, you could write that in the chat, and William can answer directly there on the chat. So thank you, William. Justas.
Yes. Do I share the screen now? Is it?
Yes.
Is it okay?
You share screen and then you go into presentation mode.
Okay. Can you see?
Yes, perfect.
Okay. So thank you for introduction. Maybe maybe the initial title of the presentation doesn't match the current title because we changed it maybe last week. So my presentation is about forest business challenges due to waterlogged soils, and I will start with a basic knowledge about what waterlogging is. So waterlogging is when water is unable to drain away, and air circulation is restricted in the soil. And when it happens, then unadapted plants experience root stress, which reduces tree growth or sometimes even death. For example, when the beavers build a dam over a forest ditch and then it floods, then you can see the unadapted trees. They just die after some time, after a year or two. And also water saturated soil is more acidic normally, which also restricts tree growth. And water logging is common on poorly drained soils or when heavy soils are compacted. So there are two ways of water logging to happen. So when the soil is compacted or when it's poorly drained. And then moisture surplus creates other problems such as challenged transportation. So the main problems are transportation and reduction in growth and production. So water level can be managed with drainage ditches to reduce the water level, and of course in forestry it's a positive thing, helping to improve the quality of transportation and the forest itself. But of course, as an environment specialist, I cannot forget the problems that hydromelioration causes, such as loss of habitats, and especially the important wetland habitats, and also greenhouse gas emissions due to peat mineralization, disrupting hydrological balance when there are no wetlands left to feed the rivers during droughts, and reduced resistance due to unnatural habitats developed in the drained areas, of which an example could be pure spruce stands planted in such areas, and then spruce having shallow roots, they cannot survive winter droughts in summer in drained peatlands, so their their immune system weakens, and they get susceptible to pests, such as in this case spruce beetle. Well, as for the transportation, we saw already a picture from Sweden today, and the left one is from Lithuania. I took it yesterday, and the right one is more severe case of the same problem. And the transportation can delayed transportation of wood from the forest to processing plant can cause process called wood sap staining, and the sap staining leads to the better or even best quality wood falling under the category of firewood and losing the value. And now for what I do, for what my little forestry business is about. I harvest birch sap. So I have a little company, and it reaches the public by communicating with buyers, and I also present my business to little communities as in a form of seminars. I also participate in scientific activities, and the academia part that I work with is Vytautas Magnus University, as well as Lithuanian Research Center for Agriculture and Forestry, and we have a few articles written together. And also I work in a public institution, Lithuanian Agriculture Advisory Service, which has a forestry department and also advises farmers. So it has a large, let's say, community of clients, and there are many people that can reach the information easily. And so for the sap business, the main problems caused by wet soils is, of course, transportation. So I adapted the transport to track machines as lightweight as possible, to easier pass the wet areas, and also to disrupt the soil as little as possible. Also, the moisture level in a soil affects the selection of forest area. So if it's a wet forest area, I immediately choose it as not suitable. And then we had we wrote some scientific articles, hypothesis of one of which was that soil moisture can affect the quality of birch sap and quantity as well. And in this graph, you can see how the yield of sap depends on forest moisture. So the first, second, and last bars represent wet soil areas, which I wouldn't normally work, but I picked them for scientific purposes. and you can clearly see that the yield from a single tree is way smaller than the yield from the areas of natural moisture. Of course, the soil structure is different. The first bar is for histosoil, and the second and third is for arenasols, and the two last are for luvisols, but of different moisture level. But then, if you memorize that the first, second, and third bars are for wetland, then in this slide, you can see that the first, second, and third graphs are a bit taller than the middle ones, or first, second, and last are taller than the third and fourth, which are dry soil areas. So even though the amount of sap is lower in the wetlands, the quality of sap, such as sugar concentration or dry soluble solids in general, are a bit higher. So the quality may compensate the quantity. Well, but it's not possible to harvest sap in wet soil for different reasons than the quality. And to conclude, I would like to stress the main aspects, that the waterlogging causes reduced yield and trouble transportation for most of the forest businesses, and that at the same time wetlands are important to the environment. So the best way to approach the issue of waterlogged forest soils are to adapt to them and not drain everything, and then that areas with high water level are not suitable for bird sap business, and have experience and methods for picking the proper forest stand in terms of soil and soil moisture. So that's the end of my presentation. Thank you, and please.
Thank you very much, Justas. If you have questions for Justas and his presentation, please write them in the chat, and he will answer those questions. Great, super exciting and interesting, Justas. Thank you.
Thank you.
And then we move over to Chermek. Chermek, if you can hear me, you need to unmute yourself.
Yeah, okay, sorry, my mistake. Yeah, okay. Hello, everyone. My name is Przemek Musa. I'm from Poland. I'm from the Bureau for Forest Management and Geodesy, and I want to present you first in Poland strategic SNAP project with acronym Wetlands Green Life. The project is in consortium with the Bureau for Forest Management, GDOP, or the General Director Environment Protection, and Forest Faculty in Agriculture University in Krakow. And the project is very important for wetlands. And the area of the project is more than 640,000 hectares wetlands in Poland. The most of this area is in the green infrastructure, but about 200,000 hectares in the Nature 2000 area. I want to present you main keys of the project. This is a very long project, about 10 years. And okay, the main keys. The key problem, and the first in Poland, we have a unsatisfactory or poor condition of wetlands in Nature 2000 areas. And we must need for update methodologies for monitoring natural habitats. And also we must need to identify wetlands in green infrastructure areas. We make database tools now, and we want a lack of public knowledge about the wetlands. So the next and the key objectives: the protection and restoration of important environmental functions of wetlands. Next, we proposing active protection tasks aimed at maintaining or improving the conservation status of natural wetland habitats. And three, it's creating a modern, multifunctional and stable countrywide system for managing natural resources. And last but not least, raising awareness of the need to protect the biodiversity of peatlands, marshes and wetlands and their environmental function. Actions. The actions, this assessment of current wetlands condition, designation of buffer zones for wetlands, peatlands and marshes, verification of current practices carried around Nature 2000 wetland areas, and implementing active conservation measures to maintain or restore important environmental functions of peatland, marshes, and other wetland areas. And the next outcomes, what we want to raising the groundwater level and stabilizing it. I think it's very difficult for us, and restoring the natural water regime to stop peat decomposition and restart peat forming process. Restoration of peat forming vegetation. And the improvement of the chemical properties of water to the state that determines the sustainability of wetland habitats, and reduction of lead content in the soil and plants to geochemical background value. So the project starting in 2023, and we are after 1 year. Now we made more than 50,000 hectares monitoring of the wetlands areas in Nature 2000 areas, and I think it's a very interesting project to make in the future, of the end of the project, to make a very high quality map and database with all information about the wetlands, so the peat, marshes, wetlands and peatlands. We know we have a very difficult problem, big problem with marshes and wetlands and peatlands, not in Poland only, but I think in all Europe. And in my opinion, in Poland, this project is very important, and they systematize all information about the wetlands, but now we have spread out the information. We can find a lot of information about very multiple databases in multiple information brochures or websites. We don't have a one big database. We can use it to the science, to the standard management. Okay, that's I think it's enough now. The key is, of course, if you have a question, thank you for your attention. If you want more information about this project, you can visit our website, www.wetlands.pl, or if you have more question, you can write to me, because parallel I have a meeting with Europe Commission, and please forgive me. I cannot answer a lot of questions. But if you want, you can write to me. If you want to make a cooperation with a network live project with us, okay, contact with me. I will write the website address and my email on the chat. Thank you very much. Thank you for your attention.
Thank you very much, Cermak. Yes, and don't forget to write your email address on the chat if somebody wants to contact you. That would be great. We have lots of questions on the chat. If there are more questions, please don't hesitate to write your comments, your questions in the chat, and we will try to answer them as quickly as we can. And by that, I really want to thank William, Justus, and Cermak for very inspiring talks. Thank you very much for that. It's been great to hear from this. Tejshri, do we have any questions that we need to answer right now?
Yeah, in the Q&A we have, I think we've answered this in the chat, but if you are looking for collaborators or you have a project in mind and you would like to find partners, please check out the matchmaking event on June 11th, or create a project in the matchmaking portal on the nation's website. We will leave the information in the chat, so you can find the links directly. We have another questions for Prashmishla. Would you like to answer?
Yeah, of course.
The Wetland project looks very interesting. Has it been developed under the Living Lab model or another? If so, what have been the challenges for collaborative work?
So Cermak, is your site, is that a living lab, or is it? I understand that this has been ongoing for so long that you might not been thinking in a living lab concept, because living labs was not a concept when you started this.
Yes, so the answer is very difficult for me, because really I can answer I don't know,
No.
and I must think about it. But of course, in maybe not in project, but in the Bureau for Forest Management and Geodesy, we also make a soil map for forest soil map in all forest state in Poland. As you probably know, it's a more than 7 million hectare in Poland, and after every 25 years we make a soil map, and we have 2 laboratories, chemical laboratories in our bureau, and I can answer that. Why not? But I cannot directly answer yes or no at this moment. Please forgive me.
No, that's absolutely okay. A question for William here. What do you see, William, as the main limitations when it comes to using AI for soils questions?
That's a good question. Well, first off is always the quality of the training data. The models are never better than the data you train on. So you need good field data. The other challenge is the quality of the LiDAR data, but I don't think that's a huge issue anymore, since most countries have actually better LiDAR data than Sweden, so I'm not that worried.
Good. Yeah, I noticed that Sweden was not one of the dark green ones, but yellow on your map.
We have 1 to 2 points per square meter, while other countries have up to 15. So I'm very jealous.
Okay. Oh well. That's
all right. But Hjalmar, perhaps a question for you from the registered participants.
Yeah.
What are the main parameters defining natural soils, non-impacted by anthropogenic factors? Any rapid assessment tools?
That's a very good question, and one that is super difficult to answer, I think. So to be honest, the whole idea of soil health is very tricky from a scientific perspective. In general, I think the health question is difficult in all aspects. I mean, what is human health? Well, it's a good quality of life, long life, and I think it's just kind of the same question when it comes to. It's hard to pinpoint what is good health for humans, and the same thing goes for soils. What is the good health of a soil? I think what we need to think about is how do we move in the trajectory of improving the soil conditions of different soils, and how do we avoid degeneration of soils? Those are the two perhaps most important aspects. And when it comes to improving the health, one issue is often to get more carbon into the soils, because carbon is important, not just for greenhouse gas mitigation, but also it's important to improve the health of the soil systems. But in a forest perspective, those are very difficult, I think, to define. So these are questions that we've been struggling with in this program when we started. What is it? How do we define soil health, and what does it mean for different aspects? And that's why we came up with these 8 different 8 different soil health issues in a forestry context. I saw that there was a chat link there with a link to the soil soil health issues related in a website. You should check that out. But I think it's much easier or less difficult in an agricultural setting than in a forestry setting. Agricultural systems are always are more or less human-made, right? Compared to forest systems, which are often natural, but often being disturbed by human processes. So I think in a forest context, it is a little bit more difficult than in other contexts. So I think avoiding the degeneration is something that needs to be considered all the time. Good. Unless there are any other questions, I want to maybe put on the slides again, because they're, at least so we get those recorded and people can find these later if they want to look at this. If they look at the recording of this, they can then identify some of the slides on there. So we've talked about what living labs are. So important thing to consider when thinking about what a living lab is, it is places for co-creation, co-design, co-implementation, and co-assessment. So there are lot of co in here, which means that it's not It is something that we do together with other actors, and that's the important thing. So if you're a scientist, well, so maybe the collaboration between scientists, the scientific community, authorities, land users, and others. At least 2 of these needs to be part of this. It is participatory, interdisciplinary, and transdisciplinary approaches. So it's really trying to not just look at one specific question from one scientific or one traditional perspective, but trying to open it up and add other approaches and other perspectives on the questions. And the idea is that the model should ensure sustainability. And I think as Justas had a very nice example of that from the work that he was dealing with. So there are 2, when it comes to soil health, so there's 2 missions calls out right now. One on the soil health 0101, with a co-creating solution for soil health in living labs, and that's kind of what we talk about. And then there's another one for urban areas. But so the deadline for the applications of this is 8th of October. So I guess it's a more than the good time to start the process now if you're interested in this. There will, as far as I understand, there will be more calls coming later. So if you missed the boat this time, there will be more opportunities coming in the future. Every application needs 4 to 5 living labs, and from at least 3 different member states. Nations, so that is the program that is put on this event. They have some services, and you could find these web link here. And again, these links will be available on the nation's homepage. So just make sure that you have the nation's homepage down, and then you will find all these for when it comes to individual coaching sessions, matchmaking session, capacity buildings, and then all thematic events that have been recorded from these. So those were the things that we wanted to talk about. Tejshri, do you have anything else you want to bring up here?
No, I think this is great. Just to say thank you to all the participants and to look out for the other events on Nations coming soon.
Good. Thank you very much, and have a good rest of the day and a good summer. Bye-bye.